So 245 तो continue करें. ये रेडी हो गया, चालू करें. पीपीटी 4:3 मतलब पूरा स्क्रीन में आना चाहिए, पूरा फुल स्क्रीन आना चाहिए. 16:2 ओके, मैं एडजस्ट कर लूंगा. ठीक है, मुझे कोई बताया नहीं था. 16:9 अच्छा हो गया. अच्छा, और एक बात, 245 तक चला सकते हैं. सर का थोड़ा देर हो गया, क्या मिल सकता है टाइम 245? मैक्सिमम 40 240 ठीक है. 40 में बंद करें. ठीक है, ठीक है. अभी 7 हम दिखाएंगे. नहीं, ऐसे ही छोड़ दीजिए, ऐसे ही छोड़ दीजिए. अभी करेक्शन नहीं करेंगे, ज्यादा टाइम जा रहा है, तो ऐसे ही हम आप दे दीजिए. कल से हम देख लेंगे और उसको एडजस्ट कर लेंगे. ठीक है, और अभी 7 हम दिखाएंगे तो शुरू कर देना. वो साउंड दे दिया मैंने यहाँ से. ओके, ओके, थैंक यू.
I welcome you all to this session on computer systems and smart devices. The objectives of this presentation, all of you should know, it's about identifying the computers, the components of a computer system. We will describe the elements of a CPU. We will also look into the concepts of networking. We'll also look into the latest plug-and-play devices and understand about smart devices later on. In today's and the next session, we'll be completing all these objectives. And before I can take you to the session, all of you should know that as information systems managers, you'll be in charge of the IT infrastructure. As the information systems manager, you'll be handling information technology, which is basically a principal means of creating information systems. Information technology, as I told you in earlier sessions, that it lays the foundation for a proper information system in any organization. So in this presentation, I'll present to you IT resources that may be used to raise the operational efficiency of an enterprise, increase the effectiveness of its management, and enhance the competitive position of the firm. We will discuss the hardware and software resources that are utilized by information systems. You need to pay particular attention to personal productivity software as it defines the working environment of each of us. You'll be regularly be using personal productivity software to improve your personal performance as well as your task performance. Telecommunication networks are a major IT resource of today's enterprise. Some of these nets may be used to support a group of collaborating knowledge workers, while others span an entire global corporation and connect it to other companies around the globe. Networks have made the world a small place to live in. The internet, which is also a cooperative network, a global network of networks, and in particular its World Wide Web facility, is changing world commerce and affects virtually all organizations. Throughout this entire presentation and the next presentation, we'll try to understand how information technology may be used to produce business results. I need to make good use of information technology in my work to produce optimal business solutions or optimal business results. Using advanced information technology for technology's sake, known as bleeding edge syndrome, can adversely affect the performance of your firm. New and appropriate information systems have to be justified as part of the solution to business problems or as tools in the pursuit of new business opportunities. Today, as all of you know, that information technology has touched almost every task and individual. Creativity and information technology. I once again repeat, creativity and information technology go together. Uses of information technology in the right way can make you creative and innovative. Once all your information technology is in the right place, it opens up a wellspring of creativity and collaboration. If you can use it in the right way, you can achieve the 3 C's: communication, collaboration, and coordination. That's why a good understanding of the IT resources is important for every manager to be able to work in the most important function, organizational function, called as the information systems function. Information technology determines the realm of the possible in today's world. So in this unit, you'll be introduced to the hardware components of information systems and learn how firms seek a competitive edge or a competitive advantage by exploiting the properties of these components of IT. First, let me tell you about how a computer system is organized. As you all are aware that computer systems are made up of many components that work together to achieve a set of specific tasks. Almost all computer systems, it may come in various shapes and sizes, have a similar, rather simple structure. If you take a look into the schematic diagram of any computer system, you'll see that it has a processor, it has main memory and peripheral devices, such as secondary storage and input and output devices. The speeds and memory capacities of computer systems have been expanding ever more rapidly over the last few decades. This basically translates into more and more potent business applications. The business applications that you find today, which uses the advanced disruptive technologies or the emerging technologies, makes business applications potent. IT infrastructure is the one that you need to set up as an information systems manager. You'll be setting up a set of physical devices initially, along with a set of instructions called as the program or the software required to operate the enterprise. You can accomplish a set of firm-wide services, which may include computing platforms, providing computing services, telecommunication services. You can provide data management services. You can provide application software services. You can provide services for physical facilities management. You can also carry out IT management, education, and other services. you have a more accurate view of value of investments from the service platform perspective. If you take a look at IT as a service platform, you'll be in a good position to provide more accurate view of value of investments. This particular diagram shows a connection between the firm, its IT infrastructure, and business capabilities. You see, the IT services and infrastructure get their inputs from the many business strategies that are formulated, the IT strategies that are formulated, and the right information technology in place. It can enhance the IT services and the infrastructure. And finally, when used properly, customers get the services they are looking forward to, suppliers get their services, and the enterprise as a whole benefits. So the services of a firm is capable of providing its customers, suppliers, and employees. Why all these three? All stakeholders who depend on the organization are a direct function of its IT infrastructure. Ideally, this infrastructure should support the firm's business and information systems strategy. All these three are linked. The right IT looks for the right IT strategy, and the right IT strategy will support the right business strategy. So new information technologies have a powerful impact on business and IT strategies, as well as the services that can be provided to customers. If you take a look at the evolution of IT infrastructure, with the evolution of the most powerful tool, the computer, general purpose mainframe and mini computers era came up in the 1950s and in the 60s. 1958, IBM first mainframes were introduced by IBM. 1965, the less expensive DEC mini computers were introduced. But the most memorable era is considered to be the 1980s till date, because the IBM personal computer was introduced in 1981, and it proliferated in 80s and 90s, which resulted in the growth of personal softwares that laid the foundation for application softwares. But 1983, we made a shift from the traditional file approaches to the database management approach, which is called as the modern approach. In the 1983 till present, we are in the client-server era, wherein desktop clients network to servers with processing work split between the clients and the servers. Networks may be two-tiered or multi-tiered or n-tiered. Various types of servers like the network servers, application servers, web servers also developed in this era. In the 1992, again, there was a shift from the client-server era to the enterprise computing era, wherein we moved towards integrating die-separate networks, applications using internet standards, and enterprise applications. Again, after these 2 decades of development, in the 2000, we moved into another computing environment, which was called as the cloud or the mobile computing environment, or the cloud and mobile computing era. The cloud computing provided computing power and software applications supplied over the internet or other networks. It was the fastest growing form of computing as compared to the other computing environments like the pervasive computing, or the grid computing, or the quantum computing, or the other computing environments of these eras. take a look at the stages in IT infrastructure evolution. This diagram shows how we moved from the mainframe mini computer era to the personal computer era, then the client server era, to the enterprise computing designs, and now we are using very often this cloud or the mobile computing infrastructure. If you take a look of the previous infrastructure, that was the ones that is shown in this particular slide. And the next slide shows the cooperative kind of arrangement of these IT infrastructures. So today, these three, the client server, the enterprise computing, and the cloud computing infrastructures are very widely adopted by managers for benefiting their organizations. If you take a look at the multi-tiered client server network or the entire network, it shows how the client is connected to various servers, providing the all-important information to the various functions from the various data sources. There were many technology drivers of infrastructure evolution. It is important for every manager to know that the power and storage capacity of the processors or the computers have been growing exponentially. And it is because of this law called as the Moore's law. And it states that computing power doubles every 18 months. And today, apart from the semiconducting technology, in order to boost the power of computers, nanotechnology is also widely used, which sinks the size of transistors to size comparable to size of a virus. So from the huge engine-like computers to the computers on the pan top to very small devices with more power has come up. It's also because of the law of mass digital storage. The amount of data being stored each year doubles. This gives a graphical representation of what I said just now. Number of transistors is growing, processing power is growing. If you take a look, packing more than 5 billion transistors into a tiny microprocessor has exponentially increased processing power. The processing power has increased to more than 2.6 billion instructions per second. So you can imagine how fast today's computers have been processing data and generating the all-important information which assists managers in their decision making. Moore's law means more performance. This is the tagline that you should not forget. Also, with increasing power, the costs of these components have been dramatically getting reduced. We have been packing more transistors into less space, and that has driven down transistor cost dramatically, as well as the cost of the products in which they are used. This shows an example of a nanotube or the nanotubes. Nanotubes are nothing but capillary tubes or tiny tubes about 10,000 times thinner than a human hair. This nanotubes, they consist of rolled up sheets of carbon hexagons and have the potential use as minuscule wires or in ultra small electronic devices and are very powerful conductors of electrical current. So data can travel in lightning speeds from one place to another through these capillary tubes. The cost of data storage, if you take a look, the cost of storing data is declining exponentially. If you take a look from the evolution of the computers in the 1950s till date, it has been declining exponentially. The power has been increasing exponentially. Since the first magnetic storage device was used in 1955, the cost of storing a kilobyte of data has fallen exponentially, doubling the amount of digital storage for each dollar expended every 15 months on an average. Cloud storage services provide more than 100 gigabytes of storage for about, say, 100 rupees. IT infrastructure, technology drivers of infrastructure evolution. If you take a look, Metcalfe's law and network economics also influence the IT infrastructure. Metcalfe's law talks about value or power of a network, which grows exponentially as a function of the number of network members. As network members increase, more people want to use it. Demand for network access increases. Declining communication costs and the internet. It has also been found that communications costs are declining, and there has been a wide acceptance of the new cooperative network called as the internet. An estimated 3 billion people worldwide have internet access. As communication costs fall towards a very small number and approach zero, utilization of communication and computing facilities explodes. There is a wide, that's why today we say it's not just computers, but it is a combination of computers and communication. So we talk about communications. These IT components, they just don't provide computing processing facilities. They also provide the most powerful means for communication. This diagram shows that there has been an exponential decline in internet communication costs also. With the rise in or with the popularity of advanced hardware and software, there has been an exponential decline in the storage costs, the network costs. And one reason that we can attribute to the growth in the internet population is the rapid decline in internet connection and overall communication cost, which is coming down exponentially. The cost per kilobyte of internet access has fallen drastically. So digital subscriber line and cable modems now deliver a kilobyte of communication for a retail price of less than 1 penny. Technology drivers of infrastructure evolution. If you take a look at the standards and the network effects, whenever you use information technology and networks, it follows certain technology standards. What are these technology standards? These are nothing but specifications that establish the compatibility of the products and ability to communicate in a network. That's why all the network components or the hardware components which are available in the market should come up to particular technology standards. Then only they can be used as part of the device or part of the network. These technology standards, they basically unleash powerful economies of scale and result in price declines as manufacturers focus on the product built to a single standard. So they unleash what? They unleash powerful economies of scale and result in price declines as manufacturers focus on the products built to a single standard. So a single standard basically makes it easier for people to buy and use it along with the other devices on the network. IT infrastructure has 7 main components. First is the computer hardware platform. Then you have on that platform, you have the operating system platforms. On top of that, you have the enterprise software applications. Along with these platforms, you have the data management and storage. Then you also look into the networking and telecommunication platforms, the internet platforms. Then you also need to take care of the consulting system integration services. The IT infrastructure ecosystem is made up of these 7 components. First is the computer hardware platform. The famous vendors are Dell, Hewlett-Packard, Apple, IBM, and the operating system softwares. The popular vendors are Microsoft Windows, Unix. These are closed source operating systems. Linux is an open source operating system, along with Android, iOS operating systems, these are some of the popular operating system platforms that are widely used in computer systems. You also have a set of enterprise software applications like SAP, which is the most popular one, along with Oracle, Microsoft, and IBM. Networking and telecommunication, they also make good use of Microsoft Windows Server, the Linux, the Cisco, Alcatel, AT&T, and Verizon. Data management and storage. In India, Oracle is popular. You also have the DB2 from the IBM. You have Sybase, Ingres, Informix, the SQL Server. Another very important and most popular data management and storage system is the MySQL, which is widely used. But for big data storage, you have the Hadoop or the Apache. Now, consultants and system integrators are from IBM, Hewlett-Packard, and Accenture. This basically shows the components, the ecosystem of today's IT infrastructure in every organization. They need to focus on managing or maintaining these 7 major components. And these 7 components must provide coordination. They need to be combined together, coordinated together to provide the firm with a coherent IT infrastructure. If you take a look, if all these components are in place, the government or the organization or a family can have the required IT infrastructure in place to start their work. So this particular slide shows you the major technologies along with the suppliers of for each of the components. The computer hardware platform is made up of client machines. There are a variety of computing machines which you can use, but the most famous ones, as you all use, are the desktop personal computers and the laptops. You also have mobile computing machines like the smartphones, tablets, tabs. The clients are served by more powerful computers called as the servers. You can have servers of various types. The blade servers are the latest servers, which are ultra-thin computers stored in racks. To provide more computing power, organizations today implement blade servers. When the data size is high or large, mainframes are also used, which are equivalent to thousands of blade servers. The top chip producers for these machines are Intel and AMD. Next, the operating system platforms. You can have operating systems of various types, catering to various requirements. Like as I told you, you can have the closed source operating systems like Microsoft Windows, or you can have the Unix or Linux that are the open source operating systems. If you take a look at the client level, 90% of the machines run Microsoft Windows. The mobiles and other multi-touch devices, they use Android and iOS as the operating system. Google's Chrome operating system is widely used for cloud computing. Organizations, for integrating their standalone information systems, use enterprise-wide softwares or enterprise softwares. They make good use of the enterprise software applications, like the applications that they procure from the applications providers such as SAP and Oracle. Middleware providers, one best vendor can be the IBM or the Oracle. Data management and storage. For database storing and for running RDBMS, you can have the Oracle RDBMS data management and storage system, or you can have the SQL Server from Microsoft, or you can have the DB2 from the IBM, or as I earlier told you, the MySQL data management and storage. Physical storage, large-scale systems like EMC Corporation, they provide physical data storage. Seagate is another popular physical storage vendor. You also have the Western Digital vendor providing physical data storage. You also have the popular SANs or the storage area networks, wherein you connect with multiple storage devices on dedicated networks. Telecommunication services include telecommunications. It can either be cabled or wireless. Telephone companies, they charge for voice lines and internet access. We get our internet facilities from AT&T and Verizon in India. You also have the network operating systems. The most popular ones are from Windows, Unix, and Linux. Network hardware providers are from Cisco. Cisco is one very popular network hardware provider. You also have Alcatel-Lucent and Juniper Networks. Internet platforms, hardware, software, management services to support company websites, including web hosting services, intranets, and extranets. Basically, you need the right kind of hardware to implement intranets and extranets to provide the many benefits to the organizations. Internet hardware server market, if you take a look, IBM is the leader, apart from Dell, Sun, and HP. Web development tools or suites are from Microsoft. The Visual Studio or the .NET is from Microsoft. Oracle Sun from Java. Adobe from Adobe, and Real Networks. Consulting system integration services are nothing but you get these integration services from firms like Accenture, IBM Global Services, HP, Infosys, and Wipro Technologies. You will see that even large firms do not have resources for full range of support for new complex infrastructure. That's why they take the system integration services for software integration and for integrating the legacy systems. Software integration to ensure new infrastructure works with the age-old legacy systems. Legacy systems are nothing but older transaction processing systems created for mainframes that would be too costly to replace or redesign. The mobile digital platform includes all of this that you see. This is the current trend in hardware platforms, like smart devices such as the smartphones, the iPhones, the Android phones, and the BlackBerry are used for data transmission, web surfing, email, and for various other activities. Notebooks are also widely used for optimized because they are optimized for wireless communication and core tasks. When you are on the move, you can make good use of tablets or iPads. Today, networked e-readers are widely used by students, faculties, and people who love to read. The Kindle and the Nook are some of the best examples for networked e-readers. Today, the smartest devices are the wearable devices like the smart watches, smart glasses, and whatnot. One of the current trends in hardware platform has been the BOYOD, bring your own device, which allows employees to use personal mobile devices in workplace. This has been one of the most important revolutions that has changed our lives, and we can now work 24/7. Consumerization of IT is an important area which is looked into by managers because they feel that new information technology emerges in consumer markets first and spreads to business organizations. First, consumers make good use of the new IT that comes up, that emerges, and then slowly adopted by business organizations. Consumerization of IT also forces businesses and IT departments to rethink how IT equipment and services are acquired and managed. Apart from the many computing environments that I told you, organizations today use quantum computing, which uses quantum physics to represent and operate on data. So non-obvious patterns and trends can be found out, and insights can be used to improve decision-making to a large extent. There has been dramatic increase in computing speed. High-speed computing can be carried out using quantum computing environments. Another important trend which is revolutionizing our world is virtualization, which allows single physical resource to act as multiple resources. A single physical resource can act as multiple resources. This is a current trend which is catching up very fast. You can run multiple instances of operating system on a particular device. Virtualization provides many benefits, like it reduces hardware and power expenditures. It also facilitates hardware centralization. So security can be enhanced and the organizational data can be kept secured for use. Cloud computing is the latest computing environment that has got wide acceptance, because on-demand computing services can be obtained over networks. Many types of cloud computing services a consumer can get. One is the infrastructure as a service, which is called as IaaS. You can also have platform as a service, the PaaS, and software as a service. You provide a subscription fee to a particular organization which hosts these services which host the servers to provide these services. So cloud can be a public cloud or a private cloud. A private cloud can be utilized by the stakeholders of the organization. A public cloud can be utilized by all citizens of the country or the whole world. It allows companies, cloud computing allows companies to minimize IT investments. This is one of the main reasons why it is becoming very, very popular these days. Also, hybrid cloud computing models are available for organizations to use. This particular slide shows the cloud computing platform. You can take a look that in cloud computing, hardware and software capabilities are a pool of virtualized resources provided over the network, often the internet. Businesses and employees have access to applications and IT infrastructure anywhere, at any time, and on any device. Green computing is another computing environment which is fast catching up. People are sensitive to climate changes and they prefer green computing. These are nothing but practices and technologies for manufacturing, using and disposing of the most hazardous waste, like the computing and networking hardware waste. Green computing generally reduces power consumption, and that is the high priority that is given in this kind of a computing environment. High performance power saving processors also have come up. Today you have access to multi-core processors, power efficient microprocessors to be used in computing devices. There has also been a paradigm shift from the traditional application softwares to software platforms which use open source, the idea of open source. Open source softwares, they are produced by community of programmers. It is free of cost and modifiable by users of that software. The best can be OpenOffice. The best example can be OpenOffice or Mozilla Firefox browser. They use open source software for its development and for its working. Linux is another kind of open source operating system, which is used in high performance computing. It is also used in mobile devices, local area networks, web servers, and Android operating systems. If you take a look, you also have a set of softwares for the web. Java is a software which is widely used as an object-oriented programming language. It is basically processor independent. That's why it's very popular and widely used today. Hypertext markup links for designing web pages are popular. Today we have the hypertext markup link 5. Web page, these are nothing but web page description languages. And the latest evolution in HTML, HTML5, it embeds media and animation. It supports cross-platform applications, offline data storage, and a plethora of services. Ruby and Python are some of the new softwares which has gained popularity. Web services, the current trends are that software components that exchange information using web standards and languages are the web services. XML is one very good example of these services, the extensible markup language. It is more powerful and flexible than the HTML, making the web pages dynamic. It's more powerful and flexible than the static HTML designs. Uh, XML tagging allows computers to process data automatically. Apart from the client-server architectures and the enterprise architecture, today also you have the access to a SOA or a service-oriented architecture. It's nothing but a set of self-contained services that communicate with one another to create a working software application. So software developers can now reuse these services in other combinations to assemble other applications as needed. An invoice service to serve the whole firm for calculating and sending printed invoices can be done using a service-oriented architecture. This is a small example that shows how Dollar Rent a Car this firm uses web services to link online booking systems with the airline's website. This diagram shows how these are linked, how this company uses web services to provide a standard intermediate layer of software to talk to other companies' information systems. It can use this set of web services to link to other companies' information systems without having to build a separate link to each firm's system. You also find in the current trends that software is being outsourced apart from cloud services. Three external sources for software are the software packages and enterprise software. The software outsourcing is done by contracting outside firms to develop software. Cloud-based software services, such as the software as a service, is part of the cloud-based software services, wherein providing a subscription, you can get access to the most sophisticated software to get your works done. The cloud-based software services can be accessed with web browser over the internet. So you need to have the SLAs, which are nothing but the formal agreements with the service providers to make use of the cloud-based software services. So this shows the changing source of farm software from total software spending to the outsourced software expenditure to the software as a service. Software outsourcing and cloud services is done through mashups and apps. Mashups are nothing but combinations of two or more online applications, such as combining map software, the Google Maps with local content. You also have apps, small pieces of software that run on the internet on your computer or on even a mobile device. Apps basically today refers commonly to mobile applications on the iPhone or the Android. They tie user to all of these platforms that we discussed. So to tying up with various platforms, you need to install an app. Now, what are the various challenges of managing IT infrastructure? All of you need to know as a manager, you'll be dealing with all these platforms that I just now discussed. And also you'll be facing infrastructure change. As firms shrink or grow, IT needs to be flexible. This is the bottom line. IT needs to be flexible and scalable. What does that mean? Today I bought an IT component and tomorrow it should not be redundant. I should be allowed to update it and use it for a little bit more period of time. So it's called that the IT component is scalable. It should also be flexible to changing needs or changing requirements. Scalability is a word which refers to the ability to expand to serve large number of users. For computing and cloud computing, there has not been many policies or procedures in place. So governments are coming up with new policies and procedures for managing these new platforms. Contractual agreements with firms running clouds and distributing software, the distributing software required is done by agencies. Management and governance. Who controls IT infrastructure? How should the IT department be organized? How are costs allocated between divisions and departments? These are some of the questions that should come to the mind of the IS manager for the management and governance of IS and IT. You need to focus on the total cost of ownership model or the TCO model. You also need to make a decision regarding rent versus buy or go for cloud computing or outsourcing. The total cost of ownership can be reduced if you make good use of cloud services, if you have greater centralization and standardization of hardware and software resources. So, having discussed all this, let us now come to the core topic of IT hardware component. If I have to look at a computer system, I have to look at the structure of a computer system. A computer system is nothing but a set of devices that can accept and store programs and data. It can execute programs by applying their instructions to the data and report the results. When we start to use our personal computer, we can interact with it through an input device, a keyboard. Under the processor's control, the input device transmits encoded symbols into memory and the output device displays them. The program that our computer is executing may be a program that tries to accomplish a specific set of tasks such as a word processor or a spreadsheet or a database management system. Indeed, what a computer does at any given point of time depends on the instructions of the program it is executing. This is why the computer is called as a general purpose information processor. The same machine, when executing an expert system program, can render advice on a complex financial deal, or running yet another software program can produce the best routes for thousands of an airlines planes. This flexibility accounts for the pervasive presence of computers in the business landscape. Computers may be of different configurations, and the devices included in these configurations, their speeds and their processing capabilities will of course be different. This is a schematic diagram of how a computer works. This shows the main component, that is the central processing unit, along with its internal components like the central unit or the control unit, the arithmetic logic unit, the main memory. But all of you should know that the CPU is not just made up of ALU and control unit. It also has the registers to store data. It works along with the main memory to produce the processing results. It takes inputs through input devices, processes it. That means it classifies, calculates, stores, and summarizes the results and throws them to the output device to be utilized. When the main memory falls short of storage, the computing system can also make good use of various peripherals. The secondary storage is one such peripheral which is widely used to support the processing activity of a computer. We stop with this, and I thank you for your patient hearing, and we'll continue discussing the hardware, software, network, and the internet components in the next session. Thank you.